Hi everyone, we're going to continue with our introduction to statistics, and this time look at section 12.3, which is on measures of dispersion. So measures of dispersion are used to describe the spread of the data items in the data set. So the key word there is the spread. Now, spread of the data means like how spread out the data actually is. So for instance, let's say I was giving an exam, and let's say I got my scores back for the exam, and some students scored really poorly. They had like 20s and 30s, and other students did really well. They had 90s and 80s, and I had some students in the middle. Well, that data set is pretty spread out, right? I have anywhere from down to 20s and 30s up to 80s and 90s. So I have a pretty far spread of my data. Let's say I gave a test and instead all my scores were kind of centered around 70. Maybe some students had grades in the 60s, some students had grades in the 70s, maybe an 80, but they kind of were all around the same point. Then that data is much less spread, right? It is much more narrow of a data set. So your spread here is really how wide is that data set? Now there are two very common measures of dispersion. So the first is the range, and then the second is the standard deviation, and those are the two that we're going to discuss in this section. Now the range is very easy to find. So the range of your data is just the difference between the highest and lowest data values in your data set. So you do want to note that the range depends only on two values of the data set, just the highest and the lowest. So it's very quick to find, but sometimes it can be problematic because if you have outliers, so maybe like one really high score, one really low score, that can definitely affect your range, right? Because you're really only using two values to compute it. So for instance, we're going to look at the ages of the 5 oldest presidents at the start of their first term. The ages are 78, 70, 69, 68, and 65. So I will note that this question is in your text, but I have edited it to incorporate President Biden because he actually is the oldest president at the start of his first term, as he is 78. And former President Trump is the second oldest at the start of his first term at the age of 70. So we have 5 data points here, and we're going to find the range of the data. So our range is just the highest value minus the lowest. So in this case, my highest value is 78, and my lowest value here is 65. So all I need to do is go ahead and subtract these two values, and that gives me my range. So I have a range here of 13 years. Now, if you look in your book, again, the 78 is not included because at the time of printing, President Biden was not president yet. So you have these 4 values, but if you want to see a nice little kind of bar graph there in your text, you can go and check that out as well. So that's the range. Very quick computation. It's nice to know because it just tells you again that highest minus lowest value, but it can be problematic because if your highest or lowest value is more of an outlier, kind of more of an exception point, and more points are centered more maybe in the middle or somewhere else, then it doesn't really show you the true range of the it shows you the true range of the data, but it doesn't really show you that much about the dispersion with like the intermediary values too. So we have another kind of measure of dispersion called the standard deviation, which is used much more frequently. And the reason it's used more frequently is because it actually does take into account every single data point in the calculation. Because of that, it is a much more complicated calculation. So the standard deviation is actually found by determining how much each data item differs from the mean. And there's more to it than just this. It's actually a kind of average. So we're going to end up squaring and dividing and adding and kind of doing these larger computations here. But the basic idea is how spread out the data is from the center. So instead of looking at the range where it's just highest or lowest, the standard deviation really focuses on how far is that data point from the mean, so from that center. Now, the first step in finding standard deviation is to just find the deviations from the mean. So we're going to go ahead and do that here for that same example of those 5 data points. And deviation from the mean is just the data item minus the mean. So before I can start here, I do have to find the mean of my sample. So I'm going to go ahead and take those 5 data values, I'm going to add them up, and I am going to divide by 5. All right, so let's take out our calculators. So I have 78 plus 70 plus 69 plus 68 plus 65. So I get 350, and I divide that by 5, and I get a mean age of 70 years old. So for my deviation then, what I'm going to do is for each x value, I'm going to take that x value and subtract it with the mean. So I'm just going to kind of make a little mini table here. So my first x value is 78, then I have 70, then I have 69, 68, and 65. So each of those x values will get subtracted with the mean, which is 70. So here, 78 minus 70 is 8. 70 minus 70 is 0. 69 minus 70 is -1. Sorry, this is a, I'm sorry, guys. This should be minus signs. I don't know why I wrote equals there. Minus. 68 minus 70 is -2, and 65 minus 70 is -5. So there are our deviations from the mean. Now, this is not the standard deviation. There's actually more computation work we have to do, but this is the first step to finding the standard deviation. Now, an interesting thing about these deviations from the mean is that the sum of them is always 0. So look, if I add these up, I get 8 plus 0 is 8, plus -1 is 7, plus -2 is 5, plus -5 becomes 0. You can actually see right here, right? These 3 values add up to -8. -8 plus 8 is 0, plus another 0 is still 0. So what happens is these deviations from the mean will always, always, always add to 0. So we can't really use them as they are to find an average to calculate the standard deviation. So what we actually will end up doing in the next step is we're going to square these values in order to help us find that standard deviation. So the standard deviation is a kind of average of the deviations from the mean. And what you want to know here, and this is important, is that the larger the standard deviation, the more spread out the data is. So let's actually go ahead and find the full standard deviation here. And you have the steps listed right here. So I'm going to go through them and kind of read them together. And then we'll just kind of go through each step one at a time. So your first step is to find, and we're going to use the same example. So our data points, let's rewrite them over here. We're 78, 70, 69, 68, and 65. And our first step is to find the mean of the data items. So we already have that. Our mean here happens to be 70. Okay, so we did that on the page before. Okay, the second step we're going to do, again, we've kind of already done, we're finding the deviation from the mean. So we're going to take each of those data items and subtract the mean from them. So I'm just going to rewrite this. So I have 78 minus 70, 70 minus 70, 69 minus 70, 68 minus 70, and 65 minus 70. Now, you don't have to be in order here, but it does kind of help. Just keeps things a little bit easier in order for your data set, I mean. Okay, so those 2 steps we've already done, and those are our first 2 steps for finding the standard deviation as well. Now, your third step is actually going to be to square that value. So you're going to take the value in your last step, all those values, and you're going to go ahead and square them. So I'm going to make another kind of column here, and this is step 3. So I'm going to go ahead and take my 8. So I'm going to do 8 squared, which is 64. 0 squared, which is 0. Now, -1 squared, this would be in parentheses, so negative times a negative is a positive, so I have +1. -2 squared, the same thing, you're going to get +4. And -5 squared is -5 times -5, so +25. When you square, all these values should now be positive. The fourth thing we're going to do is we're going to sum. So to sum means to add all of these square values that we just got. And this little notation here, as a little note here, this does mean to sum. So this is the Greek letter sigma. Okay, it's a Greek capital letter S. And we do use that in math all the time to mean to sum or to add. So you will see that notation a lot in math classes, and it's one that really follows into different math classes as well. It really follows through many different fields there. So if you see this symbol, it just means to add. So now we're going to add all these values up. So I'm going to do 64, 0, 1, 4, and 25. I'm going to go ahead and add these all up. Now, this is a pretty straightforward one, so you can do it in your head or you can use your calculator. So you have 64 plus 1, I'm going to skip the 0, plus 4 plus 25, and I have 94 for my total. Now, step 5 says we're going to take that sum and we're going to go ahead and divide it by n minus 1. So step 5 here, we're going to divide the sum by whatever n minus 1 is. Now, n is equal to your sample size. So that is your number of data points. So here we have 5 data points. So in this example, our n is 5. So our n minus 1 is going to be 4. So what I'm going to do here is I'm going to take that 94, and I'm going to go ahead and divide that by 4. Now this comes out nice and even, so if you want to, you can leave a fraction and simplify it. You can use a decimal. You can just kind of read the directions for that section and see how they want your final answer. A lot of times in stats, sometimes we do change to the decimal form. If you had more than one decimal place, though, I would use a lot more decimals here because you still have one more step to go. And the last thing is to take that square root. Okay, so we'll just come down here. So step 6 is to take the square root of your answer in step 5. So I'm going to take the square root of that 94 over 4, which is the square root of 23.5. I'm writing this down here because if this division comes out to be really messy and not even, then you may just want to use the original fraction when taking the square root so you have a more accurate answer. Now on my calculator, the square root button is right here with the x squared piece. So I hit second and then x squared, and I'm using the TI-8384 series. It's just the app version. And then I put 23.5, I hit enter, and I get about 4.8476, etc. Now in my math lab, obviously you want to read the directions to see how they want you to round, or if they want you to use an exact answer or a fraction or something like that. So you can kind of see how they want your final answer stated. A lot of times if we're using decimals, in statistics, what we typically do is use one decimal place more than what the original data is. So our original data here is whole numbers, so perhaps I would round this to just one decimal place, so 4.8. And your units here are the same as the original, so our units here are still years. And I was just checking your book. It looks like your book does use 2 decimal places for this question. So again, that is fine too. Just defer to whatever my math lab is asking for homework questions or for quizzes or tests to see how you should write your final answer. All right, so let's do it again. Again, I just brought in a really small data set because as the data sets get larger and larger, this can become quite tedious, right? Because you have to do so many different steps and do it for each data point. So I just have an example here with 4 data points, again, just so we can practice one more time. And this one is different from what's in your text. So if you want to see some more examples, feel free to check out your text here. So the first thing you need to do is you need to find that mean. So I'm going to take my 16, my 18, my 20 and my 22. I'm going to add those all up. And I'm going to divide by 4 because I have 4 data points. So I have 76. I'm going to divide that by 4. And what I get is 19. So my mean value here is 19. Now, the second thing I'm going to do is I'm going to take each of those data points and I'm going to subtract them with my mean. So my data points are 16, 18, 20, and 22. So I have my data points. So X is your data. Your book calls it your data item. And again, this is your sample mean. And I'll subtract with that 19. So here I get -3, -1, let's see, +1 and +3 here. My third step is to take what I already have and square it. So now we're going to go ahead and square the deviations from here. So I have -3 squared, which is +9, -1 squared, which is +1, 1 squared, which is also 1, and then 3 squared, which is 9. My fourth step is to add everything up. So I'm going to add the 9, the 1, the 1, and the 9, the previous column. And what you're going to see here is the value of 20. Next step is you're going to go ahead and divide by whatever n-1 is. Now, in this case, our n is 4, right? So I have 4 data points. So our n is 4 because I have 4 data points. So n-1 is going to go ahead and be 3. So I'm going to do 20 divided by 3 here. And that does not come out nice. I'm going to get about 6.6. And this is going to end up repeating. So this bar here means that 6 is going to keep going on forever and ever and ever. And then finally, my sixth step is going to be to take the square root. Now, I'm going to go ahead and take the square root of 20 over 3. Again, I could also take the square root of 6.6, but I would use a whole bunch of decimal places here, just so that my root is actually accurate, right? If you round too early, then you may not have an accurate answer. So in a case like this, you may actually just want to type in your square root with the 20 over 3. So I'm going to do second, and then that x squared key, I'm going to do 20 divided by 3, so the whole thing is underneath my root. I use my over arrow to get outside of the root, and I just hit enter. And I get about 2.5819, etc. If you don't like using that fraction there, that's okay. Just use a lot of decimal places. And you see that you'll get, again, just about the same answer. So you can see it's very close, but you do need a lot of decimal places for that to be accurate. So let's just round to 1 decimal place here. So about 2.6. And I didn't give you guys any background information, so I don't really have units in this case, but whatever your units are in the original problem, if these were ages, for instance, then my units here would also be years. So you keep the same units for standard deviation. So one last question on this section. It says 2 fifth grade classes, have nearly identical mean scores on an aptitude test. But one class has a standard deviation 3 times that of the other. All factors being equal, which class is easier to teach? So, for instance, you have class 1 and you have class 2. So it says that their means are about the same. So let's say they both have some mean, okay, and they're about the same value. And you don't have to here, but if it helps, you can always give it a number. So again, you don't have to, but maybe they both got around an 80% or something like that on this test. Now, one class has a standard deviation that is 3 times that of the other. So maybe class 1 has a standard deviation that is 3 times that of class 2. So again, you don't have to do this, but if it helps you, think about this. Let's say our standard deviation here is 5. So that would mean our standard deviation in this case would be 15, right? I'm just using STDEV for standard deviation. So even though they both have the same mean, I have a lot more spread here in my data if my standard deviation is 15, where this one, the data points are more closely together. So the larger the standard deviation, the more spread out the data is. So from a teaching perspective, it's much easier to teach students who have the same basic level of knowledge and same basic level of understanding, right? We can kind of teach one way and the whole group is kind of on the same page. So this group here, class 2, is going to be much easier to teach, right? So they both have the same mean. So they're both at like the same average in the class. But if you have a smaller standard deviation, it means your data points are clustered close together. So most of the students scored close to that 80. They were kind of really close to it. So it's going to be much easier to teach that group of students because they all have about the same level of understanding. Whereas this group, you have a standard deviation that's much larger, which means that even though the average is the same, the spread on that data is much further. So the average may be an 80, but you're going to have students who maybe scored in the 60s or 50s, those who are getting A's or hundreds. So they have a much bigger spread here. So that makes it more difficult for a teacher to teach because they have students who are at all different levels. They have some students who are really struggling, some students who are really advanced, so they may find this boring. So that's going to be a more difficult class to teach. Okay, so the big takeaway here really is that larger the standard deviation, the more spread out your data is. So depending on the situation, that could be a good or a bad thing, right? Here, not that it's bad, but this class is going to be easier to teach than this class because everybody here is at the same level, where here there's much bigger variation between the students' level. So that is standard deviation and range, of course, too. So those tend to be our two most common measures of dispersion, with standard deviation really taking on more of that. So standard deviation is used a lot in statistics and one that we tend to cite more often than the range because it does take into account all the data values, right? We have to do a calculation with every single data point. The other thing with the standard deviation is it's in reference to the center. So the range is just highest to lowest. But the standard deviation talks about the center. So it's how spread out the data is compared to the center or the average. So again, you're kind of focusing on the middle of the data group here to see how spread out it is, up and down. Whereas with the range, you're just kind of looking at overall how spread out is the data.